Woo! It is raining. Good morning, evening, or afternoon, whichever one's going on for you at this current point in time. Excuse me. Today we're going to be talking about HVAC systems. I am a jackass of all trades. That is my title. You cannot have it. And I recently took a look at a mid-2000s Honda Civic hybrid that was having no AC. Owner's been about 4 years, no AC since they got the car, and they said, I'm gonna just go get a can of refrigerant, squeeze it in. That's why her dad and uncle and aunt and everybody who's older, they just kind of squeeze on a can and hope that it's good. Do not do that to your system. Now, right here, what I have, and this is no sponsor, this is just something I picked up, is a Harbor Freight Manifold Gauge set. And what that is just a gauge that you hook up to your high and low side of your AC system, and that tells you your pressure. Remember that with R134 refrigerant, which is this case, your refrigerant has a pressure-temperature relationship. So the hotter it is outside, your pressures will increase. The lower it is, the lower your pressures will increase, and, you know, as they go. It also depends on the size and quality of your compressor and a whole bunch of other parts. We're going to make this as quick as possible, but I've already solved the situation, but I want to show you what happens because it could be several things that are going on and you might be lost and possibly be taken advantage of by somebody who's trying to sell you a compressor when you may not need it. Follow me. So to be very clear, this is the gauge, right? Pretty straightforward. What I was talking about when I say pressure-temperature relationship is that right now we are currently 52 degrees outside, and if you look right here, you can see, let me just turn off that light, you can see 52 right there on the gauge. So that tells me that with the car not running, with the compressor off, this thing is gonna be right where it needs to be. When I originally first hooked this up before fixing the situation, this was getting about 2 psi of pressure and the high side was 0. Now to be super clear, this doesn't take rocket science. You thread this coupling into the line, that line follows up, you thread it to your manifold gauge. Keep these closed. If there's nothing of a recovery tank hooked up to this, you are gonna completely paint your entire engine bay green with your refrigerant. Do not do that. Keep this closed, keep this closed. These lines have valves that keep your recovery or your charge line. These connect to your yellow. Keep these closed or this will spray everywhere. Now I already got my cold side hooked up, but this is the high. If you don't know which is which, one is always bigger than the other. Your hot is going to be bigger. Simply grab your collet, slide it back. Slide it back until it hooks to your line and give it a pull. If it comes off, it means you didn't push tight enough. You click. Once it's on, give it a tug. Now close it. When you close it, your line is going to slowly pressurize. So the temperature outside is about 50 and we are at 50 neutral pressure. This is perfect. Now when I originally hooked it up, it was at 0 on the high side and 2 psi on the cold side. I had told the individual, because Honda, when I scanned the system, gave a B2993 code. That is a thermal shorted line. That is a 3-wire, if I'm not mistaken, little circuit that is coming from your connector to let your car know if there's something wrong, do not engage my clutch to the AC. That was a false code. Typically, it was possibly an accident that happened to that car that may have damaged that line or gave it the code. Again, sensors on Hondas, especially on hybrids, is what I meant to say, not Hondas, on hybrids are going to be super sensitive. If there's any bang, any clip, any unplugging, they can give a false code. This person was about to spend probably $1,500-ish, little more, little less, on a replacement compressor, and it turns out that all they needed was refrigerant. But the reason that they didn't need to go to the can and just, to go to the store and just buy a can is because you never want to know that you potentially overloaded the system and you damaged something. So don't waste your money on just a can. You need to know if your system is empty so that you can put it to the right pressure and the right amount of refrigerant. If you put too much, which could have been the case if you just get the biggest can you could find and just squeeze 2 or 3 of them in, you're going to damage something. If you put not enough, again, your pressure switch in your AC system is going to say there's either too much pressure because you overfilled it, or not enough pressure because there's either a hole in your system or a break in your system or a leak, or there's not enough refrigerant in liquid form to make up for that pressure. Even if there's a little bit of liquid and the rest is gas form, that relationship is enough to let that pressure switch know I have enough refrigerant in the system to activate the clutch. Potentially, let's say somebody didn't want to put a compressor because it was too much of a headache. They would have gone on Amazon, bought the AC assembly for the magnetic clutch, had a new magnet, a new coil, new clutch plate, and the system would have still been there because her system was empty. So in this particular case, she lucked out. Once I recharged the system, everything is fine and she's back to blowing cold. But if your situation, let's say you filled it and it's still not engaging, you need to be looking for scanning your system for an electrical fault. Maybe a rat chewed the wire, it's possible, and you no longer have that connection. The last thing you want to do is spend almost $2,000 for a new compressor and there's no power getting to the new compressor. You're done. Check your fuses. Your AC or your blower motor can also be blown, which won't, if your blower motor is not engaging, your AC will not turn on because it's protecting itself from overheating. Or the pressure switch says, hey, there's not enough here or too much, I'm not going to turn it on anyways. So it's electrical or it's a mechanical pressurized system. Those are checks and balances that keep your AC blowing cold, but also blowing longer so they don't damage themselves for the life of the car. Now I'm going to start up the vehicle, but the first time that I actually turned on the car, hello? Okay. When I first turned on the car, you can see auto, right? When people are testing, you never want to refill your system with the recycle on. When that recycle is on in your car, you're just using the same temperature. So how do you know if your system's optimally cooling? You won't. You need to see how well it's cooling the system outside. So when you're charging the system, roll your windows down, charge your system, and make sure your car has to be on, of course, to be running the compressor. But when you turn on your system, you're going to mode it not to the defrost, not to the rear windshield, just the face, or maybe the face and the feet, as long as it's open. Make sure your AC says AC on, and you're going to feel for obviously cold air. And of course, make sure you drop the temperature down to low. And that made a huge difference. Now, for those of you who might be saying, well, dude, why are you holding your glove? Wouldn't your glove be holding it? Nope, my gloves are so worn out that this is just cloth right here, so I can feel the air. So when you turn it on, nice, cool air. Now, I couldn't give you a previous temperature because the AC was not working in the past, but the proof is in the pudding, right? Multimeter on. I have a temperature probe. If you haven't seen this, I use this for my synthetic versus non-synthetic oil for your vehicle. So check that video out. I used this temperature probe to show you that I was indeed using freezing temperatures. See this probe right here? Pretty sure you do. It's kind of tiny, but that probe right there is giving me a temperature of 62 in the car right now. System is off. That's just what we got going. So I'm going to crank on the air. Right, that is low. This is outside air because you want the proof to be low as possible with the AC on. Crank that up the max, and let's see what we got from one of our vents. Now, the reason I wanted to show that temperature is because when your system's working well, it should, rule of thumb, be that if your system is working properly, it should be about 20 degrees cooler than whatever the ambient temperature is. So previously, we're looking at about 66 degrees in the car. Whatever your system's putting out should be around 20 degrees or lower, you know, depending on how well your system is and how new your car is, or at least the components like your compressor and such. But this was about 16 degrees lower than what the ambient temperature is in the car, which is perfectly fine. Now, how long that will last? Well, that's up to you. That's why you need to keep up with your AC and make sure that they are recovering and properly charging your system with the amount you need. If you're not sure where to look at it, pop the hood. There should be a sticker right at the top when it tells you what kind of oil you need. Maybe it tells you your VIN number, what kind of gas you need for your car. There will be something that says refrigerant R134. It'll usually have a minimum and a maximum. If you're below that minimum, your clutch might not engage. If you're above that, your system is overcharged. It might be way too high pressure, and you could potentially either burn out your compressor because it's going to suck in liquid refrigerant instead of the gas form, or you could just end up blowing an actual fitting or one of the components, in which case it could puncture a hole through your hood or give you a nasty dent, potentially bounce off and damage something else. You want to make sure, if you don't know what you're doing, take it to somebody who does, or do your research. In a lot of places, you cannot allow this refrigerant into the air. It kills our planet, it kills the atmosphere, and it's not good for the environment. So do not just open your system and let everything out. This needs to be sealed systems, vacuum pumps, done the right way. Okay? Okay. What you're looking at here is a top-down view of the AC high side pressure switch. For reference, there are two in every system. It's your high side and your low side, and then all it is a little sensor or a little switch that goes threaded either indirectly or directly in line with your AC system and uses the pressures inside to send a signal to your car saying, hey, we're good, and the pressures will complete the circuit. And if the pressure drops too low or is way too high, it will stop the connection to your clutch, telling your car do not allow your cooling system to continue to be on if there's either not enough or way too high of a pressure. Now, there are two types of connections that you can have for a pressure switch, that being either a thread-in connection where you have a crush washer or a O-ring seal. Either way, you want to make sure that if there is a leak in the system, these are two things that may just happen over time. Get a new crush washer or a O-ring replacement. If you're using the O-ring, please lubricate them before putting them in. You don't know how many people in all the trades, they never lubricate the O-ring, and it ends up ripping either upon application or very shortly after, and you'll find that you have a leak in the system that sent you back X amount of dollars, and it hurt the environment because there is, once again, toxic refrigerant going out into the atmosphere. Set yourself up for success, and please check your work. That's why they say measure twice, cut once. And with that being said, that is the end of this video. However, not the end of this Honda. So thank you for watching, and if there's a question or something you have a concern about, leave it in the comment section. I'd be glad to take a crack at it. So until next time, work smart.